Section 7.4, Other Trigonometric Functions. The good news about this section is, as long as you've looked at the previous section, maybe checked out a couple of the homework problems and gotten a little practice, this next section shouldn't be too much of a leap. We are going to continue to use the same techniques that we saw in the previous section. We're going to apply them to our other four trig functions: tangent, cosecant, secant, and cotangent. But the process is going to be pretty much identical. There's just going to be a few little modifications that we'll make. So, starting out this section, we just want to look at evaluating these other four trig functions at some particular angles, right? Like we want to find tangent of pi over 6 for 1a. So as it says, above this example here, we can use reference angles. All students take calculus, all the techniques that we saw in the previous section to do this. Let's see how that would work out. For example 1, we're evaluating these trig functions. Let's start with tangent of pi over 6. Remember from the previous section, we would start by just locating the angle relative to the unit circle. So here's our unit circle. Remember, this is centered at the origin. It has a radius of 1. Where is this angle pi over 6? Well, I'll sketch the angle first. There's the initial side. The terminal side is just going to be rotated pi over 6 in the counterclockwise direction. And here's my terminal point right here. And remember, for the terminal point, the x-coordinate is cosine, the output of cosine of that angle, and the y-coordinate is sine. Okay, so if we have that terminal point is, and remember we're working on memorizing that first quadrant of the unit circle, it turns out that the x-coordinate is root 3 over 2, and the y-coordinate is 1 over 2. So I know that sine of pi over 6 is 1 over 2, cosine of pi over 6 is root 3 over 2. Now, tangent is defined as just sine over cosine. So whatever the angle is, in this case pi over 6, tangent, I could also represent this as sine of pi over 6 divided by cosine of pi over 6. Okay? And I know, I have the picture drawn already. Sine of pi over 6 is just going to be 1 over 2. Cosine of pi over 6 is going to be root 3 over 2, like that. So to find tangent of pi over 6, I can just use sine and cosine. And now I have to simplify this, which is kind of a tricky thing. We've seen the fractions over fractions before. Different ways of dealing with it. This is the main fraction bar right here, that big fraction bar, and then we have two little fractions in the numerator and denominator. The way that we can simplify this is we could turn that main fraction bar into a division sign. So this is 1 over 2 divided by root 3 over 2. And to multiply, or to divide by a fraction is the same as to multiply by its reciprocal. So this is 1/2 times 2 over root 3. And multiplying, we multiply straight across. We have a common factor of 2. Those cancel out, and we just get 1 over root 3. Or if we want to rationalize that denominator, this is root 3 over root 3. And I will put a box around that. Okay, so in this case, it was pretty straightforward because this angle right here, pi over 6, is the same as its reference angle. So t prime is equal to t, which is equal to pi over 6. Okay, so this is kind of a softball problem here. Let's look at secant. In this case, we're looking at secant of 3 pi over 4. So for this, I want to do something similar to what I did for tangent. Remember, tangent, I just sort of thought, oh, well, this is defined in terms of sine and cosine. I already know how to find sine and cosine of really any kind of nice angle between 0 and 2 pi. So, I would just sort of use that and then use that, that fraction there, sine over cosine, to find tangent. Now for secant, this is a reciprocal function. You might remember that secant of any angle is the same as 1 over cosine of whatever that angle is. So in this case, 3 pi over 4. So really, if I can find cosine of 3 pi over 4, I can then, simplify and find secant of 3 pi over 4. So let's work on that. 3 pi over 4, let's find that angle. And we should be getting a little quicker at locating these angles. Here's our initial side. Our terminal side is right here. Okay, so thinking about the unit circle, our terminal point is this one right here. Okay, what is our reference angle? We'll definitely want to use a reference angle because this time our angle T, or theta, however you want to think about it, fell outside of the first quadrant. So our reference angle is just going to be this angle. We get, the angle closest to the x-axis, in this case the negative x-axis. So that will be our T prime. So our reference angle here, T prime, is going to be pi over 4. Okay. Now, again, just working with cosine here. Cosine of pi over 4 is root 2 over 2. I got that from the unit circle. Okay, and then using all students take calculus, what is the sine of cosine of 3 pi over 4? Or maybe I should have said, what is the sign, right? Is it positive or negative, given that 3 pi over 4 is in the second quadrant? Well, all students, sine is positive in that region, but cosine is negative. Okay, so cosine of 3 pi over 4 is actually going to be negative root 2 over 2. All right, so all this stuff down here is kind of an aside. Right, so now using this, I know that secant of 3 pi over 4 is going to be 1 over, and the fraction is negative root 2 over 2. Okay, and then thinking, all right, this is the same as 1 times the reciprocal of that fraction, the denominator, so it's really 1 times 2 over negative root 2. So I'm getting 2 over negative root 2, or if I rationalize that denominator, I end up getting just, it simplifies to negative root 2. Okay, and the step in between there, to rationalize the denominator, just multiply top and bottom by root 2. Okay, so you get 2 root 2 over negative 2. The 2's cancel, and we're just left with negative root 2. Okay, so this is an effective way to evaluate the trig function, really using the process we already know from the previous section. One other note about the all students take calculus thing is if we're dealing with secant, since I know that secant is the same as the reciprocal of cosine, I know that the secant of cosine, the sine or the sign of secant and the sign of cosine are going to be the same. Okay, so this kind of gives us an alternate all students take calculus, right? For the other trig functions, it's sort of like all of them are positive here. Sine is positive over here, so cosecant will be positive over here. Tangent is positive in the third quadrant, so cotangent will be positive there. And then secant will be positive in the fourth quadrant. Okay, so you could also think about it like this, like for finding the sign of these other four I guess these other three trig functions. But I kind of prefer to just express the problem in terms of a more familiar trig function like sine, cosine, or tangent. Okay, let's keep going. How about cotangent of 5 pi over 3? So let's keep going with the same kind of process here. Where is 5 pi over 3? Okay, well I know that, let's see, how do I want to think about this? 6 pi over 3 is right here, right? 2 pi is the same as 6 pi over 3. 5 pi over 3 is just going to be 1 pi over 3 less than that, so that's going to land us right here. You also could have counted all the way around if you wanted to. You know, count by pi over 3 to get this angle right here. So there it is. Since we're in the fourth quadrant, I'll definitely want to think about a reference angle. It's going to be this one right here. So T prime, our reference angle this time, is going to be pi over 3. Now, okay, how do I deal with this cotangent here? Cotangent is the same as the reciprocal of tangent, which will be the reciprocal of sine over cosine. So here's how I can break this up in terms of sine and cosine. This is the same as cosine of 5 pi over 3 divided by sine of 5 pi over 3. Okay, so I'm going to want to evaluate both cosine and sine at that angle there. Okay, so using this reference angle of pi over 3, let's find sine of pi over 3. Can do that one first. How about, again, pulling from the unit circle, sine of pi over 3 is root 3 over 2. What about cosine of pi over 3? This is 1 over 2. All right, again, I'm using the unit circle to find those values. Now using all students take calculus, so A, S, T, C, cosine of our actual angle, 5 pi over 3, will be positive. Sine, however, will be negative. So back up to here, cosine of 5 pi over 3 is going to be positive 1/2. Sine of 5 pi over 3 is going to be negative root 3 over 2. All right, so that tells me that the output of this cotangent of 5 pi over 3 is going to be a negative value. So let's simplify now. So this is the same as 1/2 times the reciprocal of that denominator. So it'll be negative 2 over root 3. This simplifies to negative 1 over root 3. Or rationalizing that denominator, multiply top and bottom by root 3. We generally do not like radicals in the denominator. I can express my answer as negative root 3 over 3. And that is it. I'll put a box around that. Okay, we've got next up cosecant of 0. I might start by thinking, just orienting myself, I want to sort of relate this to sine and cosine. That's sort of the procedure here. This is the same as 1 over sine of 0. Okay, what is sine of 0? Well, remember 0 radians or degrees, it's the same, is just going to be, right there. It's going to be on the positive x-axis. So the terminal point, if we're looking at our unit circle, The terminal point is just right here. That's the ordered pair 1, 0. Remember, sine is just going to be the y coordinate, so it's actually going to be 0. So this is equal to 1 over 0. No need to get into reference angles or anything like that. 1 over 0. I don't like the look of this. We are not allowed to divide by 0. So what do I say about this? Like cosecant of 0 is 1 over 0. But 1 over 0 is undefined. So I just say for my solution, cosecant of 0 is undefined. All right, kind of a unique one there, but kind of quick. So that's good. We've got one more for this problem here. How about cotangent of negative 7 pi over 6? So this time we have a negative input, but don't worry, we can totally deal with this. We just have to travel in the clockwise direction to find that angle. So here's our initial side. And let's go clockwise by 7 pi over 6. That is going to put us right here. Okay. So since we're not in the first quadrant, I'll want to think about my reference angle. It's going to be right there. So my reference angle T prime will be pi over 6. And now cotangent, remember, this is the same as cosine over sine. So really I'm finding cosine of negative 7 pi over 6 divided by sine of negative 7 pi over 6. So let's evaluate both of those. Cosine, using the reference angle first. Cosine of pi over 6 using the first quadrant of the unit circle, I get root 3 over 2. Sine of pi over 6 is 1/2. All right, so this is kind of the scratch work off to the side. And then using all students take calculus. Since we're in that second quadrant, sine will be positive this time, but cosine will be negative. So we're going to get, in the numerator here, for cosine of negative 7 pi over 6, it will be negative root 3 over 2. And sine will be positive 1 over 2. And now we got to simplify, so it'll be negative root 3 over 2 times the reciprocal of the denominator, which is just times 2. And we could write this as 2 over 1. We get a cancellation of that common factor of 2, so we just get negative root 3 as our answer. Okay, so the how-to for this, just generally what we're doing, is first we break down the trig function in terms of sine and cosine. Okay, because we can do that for any of these, tangent, secant, cotangent, cosecant. And then we already have a procedure for evaluating sine and cosine functions at any of these familiar angles all the way around the unit circle. So then we'll just use reference angles, and all students take calculus to find sine of t and or cosine of t. And then step 3 is to just simplify your answer. Okay, and simplifying the answer, that's where we have to, usually it's common to deal with a fraction inside of a fraction, do that whole thing, and then you get your answer from that. Okay, so just building off of what we saw in the previous section. Okay, remember that Pythagorean identity that we saw in the previous section. Sine squared x plus cosine squared x equals 1. This is true for any real number x. There are a couple of other trig identities that are also Pythagorean, but they involve other trig functions. Okay, the tangents, the secants, the cotangents, the cosecants. And we can derive them really quickly and easily from just the original Pythagorean identity, sine squared plus cosine squared equals 1. Here's how we do it. For this first one, we're going to do 2 of these. I'm going to divide both sides of the equation by sine. Okay, so let's divide by, or rather sine squared x. Okay, so if I divide both sides by sine squared x, that's the same as dividing each term by sine squared x. Let's see what happens here. Sine squared x divided by sine squared x, that just gives me 1. Okay, cosine squared x divided by sine squared x. I'll put the step in between where the properties of exponents sort of comes in. This is the same as cosine x over sine of x quantity squared. Okay, and then the 1 over sine squared of x, that is the same as 1 over sine of x quantity squared. And I write it this way because cosine x over sine of x, we know what that is. That's a trig function. That is cotangent. So this is the same as 1 plus cotangent x quantity squared. And 1 over sine of x, that is cosecant of x quantity squared. And the last step of simplifying this is, remember, when we have an entire trig function being raised to some power, we have just this sort of clarifying notation. We write it as cotangent squared x. And this will be cosecant squared x. Okay, so here is an alternate version of the Pythagorean identity involving cotangent and cosecant. Okay, and to be completely honest, I don't really memorize this one. I will always have sine squared x plus cosine squared x equals 1 memorized. Like that I'll forget the names of my children and grandchildren before I forget this identity. And I expect you to be the same. Just kidding. Maybe not, though. Not if you're a math major. This is more important. Okay, let's derive one more. This time we're going to divide both sides by cosine squared x. Okay, so same procedure, but with cosine squared x. And let's see what we get. So I'll skip, some of the steps here, and we could just think, here we're going to have sine squared x over cosine squared x. That is going to simplify down to tangent squared x, right? Because sine over cosine gives us tangent. Cosine squared divided by cosine squared, that is just 1. And 1 over cosine squared x will give us secant squared x. So here is another Pythagorean identity. Again, not one that I have to memorize, because if I ever need to derive it, I just, divide by cosine squared x and it pops right out. Okay, so down here, these are just all 3 of the Pythagorean identities that we use pretty frequently in trigonometry. Okay, and now we know how to derive them. Okay, looking to example 2, and this is the last example in this chapter. We want to use trig identities to find tangent of x and cotangent of x, given that secant of x is equal to -2, and we're told that this angle x is between pi over 2 and pi. So this is in quadrant 2. All right, so that's going to affect all students take calculus, figuring out what the sign of tangent and cotangent are. So you might recognize this looks pretty similar to the last example in the previous section. So we're going to do something really similar here. All right, so maybe I'll start by drawing a little picture. I'll draw a little picture. I know that this angle is in the second quadrant. I don't know exactly what it is. So I'm not going to draw this to scale. I'm just going to sort of draw an angle in there. Okay. So here is my angle x. My angle x is that angle. All right. And what I want to know is what is tangent of that angle x, what is cotangent of that angle x. Now, in that last problem of the previous section, we saw that we actually didn't need to find x to answer the question. Like, we're not asked to find x in this problem. We just want tangent of x and cotangent of x. And the Pythagorean identities give us a sort of shortcut to finding the outputs of those trig functions without finding x. So let's see how we might do that. Secant of x is -2. And I have a Pythagorean identity that involves secant. It's this one right here. So what I want to do is I want to use 1 plus tangent squared x is equal to secant squared x. And tangent x is in this, so I think I'm going to start by finding tangent of x, and then I can come back and deal with cotangent afterwards. So I'm going to use this to find tangent of x. Okay, so substituting in, I get 1 plus tangent squared x equals -2 squared. Right? Because remember, secant of x is equal to -2. So that's where that -2 comes from. Okay, and I can solve for tangent squared x, and I can simplify it. -2 squared is just +4, and I'm subtracting 1 from both sides, right, to move this 1 over here. So then tangent squared x is equal to 3. I'll take the square root of both sides to solve for tangent of x. And whenever we do a square root of something squared, we get a plus or minus. So plus or minus √3 is what tangent will be. So which is it? Is it plus or minus? Well, remember, all students take calculus. Since we're in the second quadrant, sine is positive, but tangent and cosine are going to be negative. Okay, so you could just remember, like, tangent is involved in all students take calculus, so I know that it's going to be negative for that reason. Or you could think, tangent is equal to sine x over cosine x. And if sine is a positive number and cosine is a negative number, a positive divided by a negative is a negative number. So you could also think about it that way. So anyway, it's actually not going to be plus or minus. It is going to be minus. So tangent of x is -√3. I can go ahead and put a box around that because that's one of the values I was asked for. And now I want to find cotangent. Okay, so I'll take this, keep working over here. So now we want to find cotangent of x. Now this is going to be pretty straightforward because cotangent is a reciprocal function. Cotangent of x is equal to 1 over tangent of x. So cotangent of x will be 1 over negative root 3, or rationalizing it is going to be negative root 3 over 3. Rationalizing that denominator, that is. And there it is. No need to use another Pythagorean identity. I don't need to mess around with this one. I wouldn't want to because I don't know what cosecant is. I just knew what secant was. Fortunately, I could get away with just taking the reciprocal of this first answer that I found for tangent, and that gives me cotangent of x. Okay, so just making use of these Pythagorean identities to solve for these trig functions without solving for the angle x. Again, you can compare this to the last example in the previous section. We did something very similar to find sine of t when cosine of t was 24 over 25. I think it's a good idea to compare these two problems and see that it's a very similar process, just using a different identity. Okay, congratulations. We finished chapter 7. Good luck on the homework. Have your notes open. Let me know if there are any questions, how I can help. And we'll move on to chapter 8 after this one.